This is lesson 11.5 on geometric probability. Probability, as you're probably aware, is simply the answer to the question, what are the chances? Or what is the probability that? In geometry, we determine probability by examining areas. We call it geometric probability. So for example, if I were to spin a spinner like this right here, and assuming it were fair and that each area was of equal size, of equal size, I might ask a question like, what are the chances of spinning a 1? Hopefully you know immediately, there's 4 numbers up here, 1 is one of them, the chances are 1 in 4, or 25%, and that would be correct. Similarly, I could ask you, what are the chances of spinning an even number? Hopefully you know that's 2/4 or 1/2 or 50%. I do want to point out that the lowest probability, so for example, what are the chances of spinning a 5 on this wheel? Would be 0%. The highest probability of anything would be, for example, what are the chances of spinning a number 1, 2, 3, or 4? And the highest percent chance is always 100%. Okay, so how do we find geometric probability? You can read all this, but the most important thing is that to find the probability, you take the area that you want something to land in or that you want to choose, and you divide that by the area of the entire thing. The way I shorten this is to simply say the probability is want over can. So let's look at an example. Here I have a game board. What are the chances, assuming that a dart lands on this board, that it lands in the shaded area? Well, as I've told you before, it's going to be want over can. The area that I want is the area that is shaded, and I divide that by the area that I can land in, which is the area of the entire thing. That's a square. Okay, so this is what we need to find out. I'm going to move off to the side to find the area of the shaded region. Now, obviously, I think you'll see this is a very strange region, or it's a very strange shape. We don't have a formula for that, but we can figure it out because we know that it's the whole thing, the area of the square, and from that we have to subtract the area that's not shaded, that's the circle. Okay, well the area of the square is just going to be 12 times 12 minus the area of a circle is pi times r squared. Well, the radius is half of 12, which is 6. So I have found the area that's shaded. It's 144, 12 squared, minus 6 squared times pi over the area of the square. Well, we've already figured that out. It's 12 squared, or 144. I'll plug this in the calculator to find the probability. Because I have 2 terms on the top, I'll need to put them in parentheses. Close it off and divide by 144. It should be a number between 0 and 1, and it is. I would say it's about 215, which is 21.5%. What is the chance? The chance is 21.5%. I think you would agree that the purple part makes up about 1/5 of the game board. Okay, this is even easier. The area that we want it to land in is the black rectangles, and the area that it can land in is the area of the entire board. Okay, let's just count tiles. 6 plus 5 is 11, plus 4 is 15, 18, 21, and the entire board is 6 by 6, which is 36. I can simplify this fraction either in my calculator or just dividing through by 3. Okay, now in this section we're also going to look at sectors of a circle and segments of a circle. And a sector is simply, I would say, a slice of pie. It's between an arc and the central angle there. Okay, the area of the sector is simply going to be n over 360, where n is the angle at the center of the circle, times pi r squared. Find the area of this right here. I'll let you know. I had in mind this slice right here. That looks terrible. I'll just draw it with my pen. Let's talk about this slice right here. Okay. Well, the area of a sector of a circle is simply n over 360 times pi times r squared. Well, the diameter of this circle is 12, so the radius is 6. N is the measure of the angle. I don't know if you can see that or not, but it's 57. And we'll just plug this into the calculator as it is. 57 divided by 360 times pi times r squared. 17.9 approximately. And that is B. Now we're going to do geometric probability. What are the chances that if I pick a point at random, it lands in this region? Now, I could do 1 over can, the area that we just found out, 17.9, divided by the area that it can land in, the entire circle, pi r squared. I could do that, but because this is a circle and I'm looking at probability, all I have to consider actually is the degrees. The measure of our region is 57 degrees. The area of the entire circle is 360. And in both of these situations, it's equal to approximately 0.158. Okay, what if we add 2 together? So in this situation, I'm adding this one and this one to find the area. I'm simply going to plug those, I'm going to add those together. N is going to be 35 plus 45 over 360 times pi. I have a new radius of 9 squared. I don't really care what that is exactly. You can plug it in your calculator. Now, if I want to find a probability, again, I could figure out the area of the two regions together and then divide it by the area of the entire circle, or I could just look at the degrees. 80 degrees in our two regions divided by 360 in the whole circle. This simplifies to 2/9, which is about 22%. Finally, the segment of a circle, you can see here in this picture that it is simply a sector without this triangle here. So to find the area, we're going to find the area of the sector and subtract the area of the triangle. In this situation, we need to find the area of all three of these shaded regions. Well, each one of these is a segment, so I'm going to find one of the segments and then I'm going to multiply that by 3. So the area of the segment is the area of an entire sector minus the area of a triangle. I don't have much room on this page, so I'm actually going to go to the next page, and I'm going to hopefully reproduce it there. I'm going to draw one of these. Let's go ahead and do a little bit of thinking about this real quick. Because the diameter is 12, this is 6, and because this is a hexagon, I have 1, 2, 3, 4, 5, 6 triangles. Each one of these central angles is going to be 60 degrees. So this triangle I'm going to recreate on the next page. Actually, this sector. There was the triangle and the flat. 60 degrees here, 6 right here. So I'm going to find, hopefully, the area of the entire sector. Use our formula, n over 360. We've already figured out the measure of the angle. Times pi. We know the radius is 6 squared. Okay. You can approximate this in your calculator, but hopefully you can see this is actually equal to exactly 6 pi. That's easy enough. Now we find the area of this triangle. It's a little bit uglier. I do want to point out that because this side is also 6, we have an equilateral triangle, right? And so let's redraw that. 60 degrees, side is 6. And I'm going to split this down the middle and make a 30, 60, 90 degree triangle out of it. That's one of our special triangles. And the hypotenuse is 6, the short leg is half the hypotenuse, and the long leg is the short leg times the square root of 3. Okay, I can find the area of this triangle based on this. The area of a triangle is 1/2 base times height. 1/2. Well, the base of this triangle, if that part's 3, the entire side is 6, and the height of the triangle is the length of the long leg, which is 3 square root 3. This simplifies to 9 square root 3. So I've got the area of my sector, the area of my triangle. Now I can find the area of one segment. The area of the sector is 6 pi minus 9 square root 3. We can plug this in our calculator, get a nice approximation. 6 times pi minus 9 square root 3. It's 3.26 about. Now, that's the area of this one segment right here. They asked to find the area of all 3 of the segments, so I need to multiply that number by 3. find the area of the shaded regions. So I'll put regions, area of regions, multiply that by 3 in the calculator, times 3, 9.78. Okay, 9.78. One more question. What are the chances that if I pick a point on this circle, it's in one of those regions? I'm going to do want over can. The area that I want to land in is about 9.78. The area that it can land in, well, it's a circle, pi r squared. So I'm going to divide 9.78 by pi 6 squared. And it's about approximately 0.087. Okay. Yeah, I'd say that's about a 9% chance. It's a very small